Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this AWS Data Engineering Certification course, and in this particular video we are going to talk about the best practices of the Amazon RDS. So in the previous few videos we have covered RDS in a very extensive way. We have already covered the theoretical aspects of RDS. We have covered concepts like availability zone, regions, local zones, bandwidth zones. Then we covered concepts of how we can set up RDS, how we will be able to set up the different database engines that are available inside the RDS, as well as we also created a kind of event-based workflow in which we uses AWS SQS, we uses Lambda function, we used Lambda function, and we used RDS with MySQL database engine, where using SQS we were simulating a kind of record that was being sent. We were triggering Lambda function based on that particular event, and we were storing the data in our RDS table. So with that, so we have already covered these concepts, and if you are someone who is looking to get a good in-depth information or good in-depth knowledge of RDS, I would highly recommend you guys to watch those videos also. So with that said, let's get started with this video and let's get straight into the system. So today's topic is going to be that how we can basically optimize our RDS. And again, with the documentation, with the certification point of view, this particular topic is going to be an important one, right? Because in certification exams, as we have already learnt about the thing that we will not be getting something as a correct or incorrect options. There we have something called as distractors, means even that particular option is correct, is near to the correct answer, but we have to choose the most appropriate option that is available for that particular question, right? And that's where the in-depth of that particular service or the in-depth knowledge comes into picture. Okay, so best practice for Amazon RDS. Learn best practices for working with Amazon RDS. As new best practices are identified, we will keep this section up to date. Okay, so we will be covering topics like Amazon RDS basic operation guidelines. Then we will talk about the database instance RAM recommendations. Then we will talk about keeping database engine versions up to date, AWS database drivers, then using enhanced monitoring to identify operating system issues, using matrices to identify the performance issues, then tuning queries, best practices for working with MySQL, best practices for working with MariaDB, best practices for working with Oracle, best practices for working with PostgreSQL, and best practices for working with SQL Server. So all of the database engines that are available in RDS, we will talk about all of them. Then working with database parameter groups, best practices for automating database instance creation, and AWS RDS new features videos. Okay. So it's a kind of video section. Obviously, we'll not be covering the video part of it. So note, for common recommendations for Amazon RDS, you can see this particular link. So Amazon RDS basic operational guidelines. So the following are the basic operation guidelines that everyone should follow when working with Amazon RDS. Note that the Amazon RDS security service level agreement, that is SLA, requires you to follow these guidelines. Firstly, use matrices to monitor your memory, CPU, replica lag, and storage uses. You can set up Amazon CloudWatch to notify you when the user's pattern changes or when your deployment approaches the capacity limits. This allows you to maintain system's performance and availability. Okay, so there is a SLA that we will be, or that is a kind of default agreement between us as a user and AWS as a service provider. When we were launching our instances, right, there we had seen that if we are launching, let's suppose the dev environment, right, or I would say in a single availability zone environment, the availability that was I would say that was told by AWS was 99.5%, right? So there is a 0.5% of downtime that AWS says can happen on the RDS when we are going ahead with a single availability zone deployment. When we are going ahead with a multi-availability zone deployment, so the availability was it drastically improved, and the availability went to 99.95% as far as I remember correctly, right? So it was 99.95% of availability, means there is some only a few hours of downtime that can happen, right, for the multi-availability zone deployment. But in order for that SLA agreement, right, to be a kind of legal agreement between us, these are the things that we need to follow. So the first thing is that our monitoring on our RDS instance should be set up, right? We should monitor our memory, our CPU, our replica lag, and the storage uses. Okay. We can set up Amazon CloudWatch to notify what kind of users pattern are we having, right? And when the deployment approaches the capacity limit, means when the machines that are deployed, they are approaching the limit capacity. As I have already mentioned these things multiple times also, that we can set up some kind of triggers, right? Some kind of notifications to us on particular threshold. Let's suppose our CPU users has gone beyond 80%. In that particular case, I can set up a notification, maybe a SNS, that is simple notification service, maybe a kind of email that it will trigger, right? That I would say our whole infrastructure is now under some kind of heavy uses. Okay. This allows us to maintain the system performance and availability. Now scale up your database instance when you are approaching the storage capacity limits, right? So when the storage capacity limits are approached, means let's suppose if you are having 1000 GB of storage currently. To begin with, I created an instance which was having 1000 GB, or I would say 1 terabyte of 1 TB of storage, right? Now when I'm approaching the storage capacity limit, let's suppose again I have taken a threshold of around 80%, means when 800 GB of storage capacity gets full, right? Only 20% is remaining. In that case, I should scale up my database instance, right? If my storage capacity goes beyond 1 TB, right? And then I am saying AWS and giving the thing of the SLA that, okay, you did not follow your SLA. So that thing does not belong to AWS, right? That is not an issue with AWS. That is our issue. Means our system requires more bigger instance, right? Requires a bigger instance with a higher capacity, but we are not scaling up our instance. So we cannot raise a kind of SLA in that particular case. You should have some buffer in storage and memory to accommodate unforeseen increases in demand for your application. Okay. So there should be always, as I told you, right, that the maybe the trigger that we will be setting up, we will not set up it at 100% or maybe at 99%. We will set up at, let's suppose, 80%, maybe 75%, right? So that we have some kind of buffer, we have some time in our hand that we can act upon that particular thing. Then enable automatic backups and set up a backup window to occur during the day low in the IOPS. That's when a backup is least disruptive in your database uses. Okay, so we will create a kind of automated backups. How we will create this backups and backup windows, I have already talked about it when we were trying to create the database instance using the full configuration mode, right? So here we will set up the backup window. Okay, we will set the backup window and the automated backups, and it should always occur in the daily row in the right IOPS operation. Means when we are having the least traffic, daily low means when we are having the least traffic on our application. It can be majorly in some kind of I would say late at night, right? That's the point of time. usually when we have a low traffic, right? So at that point of time, I will be creating my backup window. That's when a backup window is least disruptive to your database users. Okay, so obviously creating the backup and doing the data transfer will require some kind of compute, right? It will take some time, right? And in that particular case, when we are having our daily low, or I would say the least traffic, in that particular case only, the backup will be least disruptive, means it will create the less, like it will create the least amount of issue for us. That's what you can understand. Okay, now if your database workload requires more input output than you have provisioned, recovery after a failover or database failure will be slow. To increase the input output capacity of a database instance, do any or all of the following. Okay, now we also are aware about that we can provide our own input output capacity to the database instances, right? Again, I will say that when we are provisioning our full configuration instance, in that particular case, we have the option to provision our input output database workloads, right? So here, if our database workloads requires more input output, I would say input output bandwidth than we have provisioned, so obviously there will be a failure, right? Our database, you can say, or I would say our whole infrastructure in that particular case will get failed, right? So recovery after a failover or a database failure will be slow, right? So if our database has failed, right, if our instance has gone down, in that particular case, recovering our instance will be time consuming and it will be slow. Now to increase the input output capacity of the database instance, we can do any of the following. Firstly, what we can do, like any of the following or all of the following. Firstly, we can migrate to a different database instance class with a higher input output capacity, right? Simply means that we can scale up our instance. Okay. Convert from magnetic storage to either general purpose storage or provisioned input output IOPS, right? IOPS storage. So again, we have talked about it that magnetic storage is the uh, least used storage, right? I would say, or it is the oldest storage type, right? And it is pretty much slow, right? When we usually had a kind of our floppy disks and CDs, right? In that particular case, we had our magnetic storage device, and then when till the time this SSDs and all came, then we started that particular thing uh, can be related with the general purpose storage or the provisioned IOPS storage. Okay, depending on how much of an increase you need. For information on available storage types, you can see on this particular link. So we are already aware about this fact that we have majorly three types of storage available in RDS. First one is the magnetic storage, second one is the general purpose storage, and the third one is our provisioned IOPS storage type, right? Now, if you convert to provisioned IOPS storage, make sure you also use the database instance class that is optimized for provisioned IOPS. Okay. Now it's not just that we only have to switch from the magnetic storage to provisioned IOPS storage. We should also use the database instance class which is optimized for the provisioned IOPS storage. So let's suppose if we are using the standard class, right? Again, if we are okay, let me do one thing. Let me keep showing you guys the thing on the dashboard also, so that you guys will be in a better position to understand the things. Okay, so if I do sign into my AWS account, and if I go to Aurora and RDS, okay, let's say I'm changing it to, let me change it to AP South 1. And I should go back to databases. Okay, Now I will create database, and here I will try to go ahead with the full configuration mode, right? Now we were talking about what? We were talking about the instance classes, right? So if I come here at somewhere, we should be able to see. Let's suppose if I'm going ahead with Postgres, okay. So here it's production. This is what I have to do, self-managed. Okay, here you can see, right? Database instance class. So we have the standard class, we have the memory optimized class that includes R classes, and then we have compute optimized class. So if we are using the storage types as provisioned IOPS SSD, or so there are again two types of provisioned IOPS SSDs, that is IO1 and IO2. So obviously IO2 is of the latest version. So here you can see low latency, high durability, and it is suitable for input output intensive storage. Okay. So if I'm choosing this provisioned SSD, so I should go ahead with either the memory optimized class, or I should go ahead with the compute optimized class. Okay. So this is what it's saying, that we have to, if you convert to provisioned IOPS storage, make sure you also use the database class that's optimized for the provisioned IOPS. For more information, you can go on to this particular link. Now, if you're already using the provisioned IOPS storage, provision additional throughput capacity. Okay. So here you will see, okay, here provisioned IOPS, right? So here you will be able to set up some kind of throughput capacity. So here the provisioned IOPS value must be between 1000 to 2,56,000, right? And this is it will also depend on the allocated storage, how much storage you have, that's how much provisioned IOPS you can put here. Okay, if you will click on info, so the requested number of IOPS operation per second that the database instance can support, right? Your actual realized IOPS may vary on the amount you are provisioned based on the database workload and the instance type, right? So maximum 3000 IOPS it can do in 1000 seconds. If I do it 30,000, right, it is able to do, right? But let's suppose if I'm doing here, I guess 2 lakhs, it will not take. Okay, it's taking. So if I'm keeping it, let's say something like this. Okay, it's fine, right? So here if I put, let's suppose as 2 lakhs. Okay. So here, so because this IOPS ratio to GB ratio must be between 0.5 to 1000, right? So if I'm taking a low storage here, let's suppose if I'm taking 100, right? Yes, in that case you can see, right, I'm getting that maximum IOPS allocated storage is 1000 only, right? Because here I have taken the allocated storage as 100 GB only, right? So provisioned IOPS and allocated storage also must have a ratio of 500 and 1000, sorry, 0.5 and 1000, right? So I will have to increase my storage in this particular case. Now you can see, if I have increased my storage to 10,000, now you can see I can have 2 lakhs input output operation per second on this particular instance what we will be creating. Okay, so provision additional throughput capacity. Now if your client application is caching the DNS data in your database instance, set the TTL value of less than 30 seconds. The underlying IP address of the database instance can change after a failover. Caching the DNS data for an extended time can thus lead to the connection failures. For your application, might try to connect to the IP address that is no longer in service. Okay. Now let's suppose if my application that is there, my client side application, it is caching the DNS data of my DB instances. Okay. Means DNS data means again, if I talk about, let's say, Amazon.com. So Amazon.com is a DNS, right? It is a domain name service. So Euron.1. So Euron.1 is the DNS. Ultimately, Euron.1 is running on some kind of instance itself, which is having an IP address associated with that particular machine. But if I directly give you that particular IP address, it will be difficult for you to remember. You can access through the IP address also, right? But it is difficult for us to remember the IP addresses. I can very easily remember the domain name, right? So that's how it is, that our IP address, it gets usually associated, or it gets connected to the DNS or the domain name service. Now, if we are storing this particular DNS in some kind of cache, or if we are caching it, we have to set the TTL value, that is time to live, means for how much time it should get cached inside our caching system. I can use maybe Redis, maybe I can use some kind of AWS caching service itself, right? But in that particular case, the TTL value should be less than 30 seconds. Okay, means the DNS name should not be available inside our cache for more than 30 seconds, because maybe the underlying IP address of the database instance can change, right, after a failover, and our application may try to connect with the IP address which is no longer available in the service, and for that reason we must set our TTL to less than 30 seconds. Now test the failover of your database instance to understand how long the process takes for your particular use case. Also test failover to ensure that the application that accesses your database instance can automatically connect to the new database instance after the failover occurs, right? Now this is a part of the testing part. So this is what we usually call as a stress testing, right? That we we put some that much of stress, right, or we provide that much of I would say I can say we overwhelm our architecture, or maybe our infrastructure, right? Not our architecture, I would say. We overwhelm our infrastructure in such a way that it gets failed, right? Let's suppose I am so first of all I will test the stress of it, that let's say I am claiming that I can have maybe 10,000 concurrent connections at any given point of time for my instance, right? Now so we have multiple testing packages for it. It's not that I have to make 10,000 users manually sit and connect to my database instance, right? We have packages for that who try to simulate those users. And using those testing packages, we will try to we will try to hit our server or maybe our database instance on a 10,000 requests per second, right? In that case, our database instance can go down. So first of all, we will get to know that exact figure, that okay, for my database can stand up till, let's say, 9,000 concurrent users, maybe 9,500 concurrent users. So I can set up first of all a kind of notification to me, that let's suppose when 9,000 or 8,000 concurrent users are on our platform, I should start thinking about, or I should start spinning up a new instance, okay, so that my system does not go down, right? So I have first of all the exact number, that at what number my system fails. Secondly, if there is any kind of automated backup plan that we have, maybe some kind of fault tolerance, or maybe some kind of backup database that we have. So in this case, right, where is my RDS, right? So it should automatically get, if currently my users, right, my users are getting connected to this database, right? Now in case of failure, if this database has failed in case of the stress test, now am I getting automatically rolled over to this standby database or not, right? This thing will also get tested in case of this particular test failover thing, or I would say the stress testing part, right? So these are the things, right, that the basic operational guidelines are there for RDS. Now, database instance RAM recommendations. So an Amazon RDS performance best practice is to allocate enough RAM so that your working set resides almost completely in memory. The working set is the data and the indexes that are frequently in use on your instance. The more you use the database instance, the more the working set will grow. Okay. Now, what does this particular line means? Okay. So let me just tell you in this way. Let's suppose we are having a database, right? And in database, for sure, we are going to have multiple tables, right? Again, these tables will have different number of rows, different number of columns, right? And different schemas also, right? So these are or I would say this database will have different tables. And now I will start accessing these tables, right? So our database instance has what? It has three things majorly, right? It has cores, or what we usually call as CPUs, right? vCPUs, right? CPUs, right? It has RAM and it has SSD, that is the storage. Also, it has bandwidth and all those stuffs, but currently let's understand about this much only. Now, whatever data we will frequently collect from this particular database, or we will frequently access we will access from this particular database or my RDS instance, that data will reside inside the RAM. Okay, that data will be transferred inside the RAM. Now we should be aware about the fact that our frequently accessed data is how much. Let's suppose my frequently accessed data is, let's say, 20 GB. Okay, so our RAM should be more than this. So it can be, let's suppose, anywhere around 32 GB, right? And again, it should not be, let's suppose, if my frequently accessed data is 20 GB, I'm taking 24 GB of RAM, because only handling or only storing the data is not the only job that RAM has to do. It has to also do multiple computations. So there should be a good amount of memory that should be left, right, to do the computation part also. Okay, so let's suppose we can take 32 GB of RAM instance in this particular case. Okay, and this is what it's saying. And the more we will use the database instance, the more the working set will grow, right? And as like, the more we are using the database instance, more working set will grow, and this number will keep on growing. So automatically we will also have to keep an eye on this particular number, right? That if suppose I have launched the instance with 32 GB of RAM, now tomorrow this data grows bigger to 30 GB, then I will have to scale up my instance to maybe a 64 GB RAM, right? And like that. So this is what the RAM recommendation here is saying. Now, to tell if your working set is almost all in memory, check the read IOPS matrices using the CloudWatch. Now, how I can get to know, right, that our working set is how much in the memory and how much currently the size of my working set is, and all those things. So here we will have to read the read IOPS metric, right? So currently we don't have any kind of database instance up and running, right? But if we'll, okay, let me just check the CloudWatch here. I duplicate it. Here, if I go to AWS, here if I search for CloudWatch, maybe if any previous uh, data it must be having. So CloudWatch, if I go to logs, no matrices, all matrices. So this is for the CloudWatch. Just check. We'll have to launch an instance only, then I will be getting those data. Create a default dashboard, view logs, view events. No, this is what I want. Infrastructure monitoring. Monitoring. Okay. Okay. So, just understand for right now, right? There will be a matrix when we will be launching our RDS instance, right? In the RDS dashboard itself, we will not even have to go to this CloudWatch. When we will launch an instance, we have an option of a dashboarding kind of stuff, right? Where we can get all the options of the uh, to visualize the things, right? Then only we will get this particular matrix, that is read IOPS matrix, right? Uh, while the database instance is under load. And using this read IOPS matrix, we will be able to figure out that how much RAM capacity is needed. The value of the read IOPS should be small and stable, right? In some cases, scaling up the database instance class to a class with more RAM results in a uh, dramatic drop in the read IOPS. In these cases, your working set is not almost completely in memory. Continue to scale up until the IOPS is no longer drops dramatically until after the scaling operation. Or IOPS is reduced to a very small amount. For more information on monitoring database instances, you can go on to this particular link, right? But majorly we have to focus on this particular matrix, that is read IOPS matrix. Now, keeping the database engine versions up to date. So regularly upgrade your database engine versions to maintain security, performance, and compliance. Amazon RDS releases new minor and major versions to include security patches, performance enhancements, and new features. Running an outdated database engine can expose your workload to known vulnerabilities, compatible what do we say compatibility issues, okay, and reduced support for AWS and database vendors. Now what does this particular paragraph means is, now what happens, we have different versions of the database engines, right? If we come back here again, we will be able to see different versions, right? So we have Postgres 11, right? We have Postgres 11, then we had Postgres 12, Postgres 13, 14, 15, 16, 17, and now the latest version is Postgres 18.1, right? We have, okay. Now what happens is, when developers develop Postgres 11, right? So obviously it will be having some lesser features as compared to Postgres maybe 12 itself, or for 18 if I compare. So obviously it will be a pretty outdated database engine, right? It will have some kind of security issues. It will have some kind of vulnerabilities that is now exposed to the world. And if you are still using Postgres 11, then it means you are exposed to those vulnerabilities, right? Anyone who is aware about the vulnerability will be able to uh, cause harm to the database, okay. So it's recommended that we should stay up to date with our database engines. So it will also enhance our security. It can also enhance our performance, as well as we will be able to follow all the compliances, right? So RDS itself, it releases the minor and major version updates that are available from any of the database vendors that are available, MySQL, Postgres, right? SQL Server, Oracle database, MariaDB, and all these databases, which also includes the security patches, right? If security patches is exactly the same, if we have any kind of vulnerability, those vulnerabilities will be taken care of in the newer updates. Performance enhancements, right? Obviously, performance is one of the major things which the versions focuses on, right? And adding the new features. Running an out-to-date database engine can expose your workloads to the known vulnerabilities. Compatibility issue can be there, and reduce support from AWS and the database vendors. Now, to minimize disruption, consider the following when you plan upgrade. First, test in the staging environment. Validate the new version against your workload before you upgrade the production databases. Okay, so it's not directly that you wake up one day and you upgrade your database in the production, right? First of all, we have to test it in the environment, inside a testing environment, or maybe inside some kind of staging environment that we have. So first of all, we will have to test that if the newer version is able to get my workload, it's able to fulfill all the requirements that we have, and then only we should be upgrading the production databases. If any kind of code changes is required, maybe some kind of there is some kind of compatibility. Why I'm slipping every time. Compatible. Okay, so compatibility issue, if there is any time, okay, so we have to even fix that particular thing if we are upgrading our things, right? Let's suppose we have an older version of the connector that we are using. Maybe it is not compatible with the newer version of the database. In that particular case, we will have to upgrade our connector also, and all these things we have to first of all check, figure out in the staging environment or in the testing environment, and then only we will be upgrading our databases in the production environment. Use Amazon RDS managed updates. So enable automatic minor version upgrades for easier patching. Okay, so minor upgrades we will not be able to, like, there is no kind of need, I would say, that we should be checking, or we should be first of all testing it in the staging environment, and then we should do the minor upgrades. Minor upgrades is what? Okay, if I talk about the minor upgrades here, so here if you will see, so from 17.2 to 17.4 to 17.5, 17.6 and 17.7. So these, the base version is the 17th, Postgres 17 itself, right? These are some kind of minor upgrades that happened. So these minor upgrades can be done directly to the production also. Okay, these minor upgrades can be done directly to the production also in an automated way, where we will enable the automatic minor upgrade versions. Now, if you are using the version 17 and now the version 18 has come, it will not directly upgrade from version 17 to version 18. It means AWS will not directly upgrade it from version 17 to version 18 unless we haven't done it in a manual way. And for doing this major upgrade, first of all, we should test our things in the staging environment, and then only we should go ahead with the major version upgrade. Now, schedule major version upgrades, review release notes, test application compatibility, and then plan a controlled upgrade window. Regular updates help ensure your database remains secure, optimized, and aligned with the AWS best practices. Okay. Now comes our AWS database drivers. So we recommend the AWS suite of drivers for application connectivity. The drivers have been designed to provide support for faster switchover and failover times and authentication with AWS Secrets Manager, AWS Identity Access Management, and Federated Identity. The AWS drivers rely on monitoring database instance status and being aware of the instance topology to determine the new writer. This approach reduces switchover failover times to single digit seconds compared to tens of seconds for open source drivers. As new service features are introduced, the goal of AWS suite of drivers is to have built-in support of these features. You can go on to this particular link and check for the connectivity. Now, what does drivers are, right? So drivers are the I would say the engine, right, using which we are able to do a kind of connectivity to the databases. We are able to do the read operation, we are able to do the write operation, and the drivers are so drivers is internally is nothing but a kind of code which happens and which manages everything inside a database. Okay, so if we are going ahead with the AWS drivers, right, in that particular case, the failover digits and the kind of database queries that we are having, we get an instant awareness about those things. Okay, and this approach will do what? It reduces the switchover and the failure times to a single digit seconds. Means we will be able to do the switchovers and the failovers in less than 10 seconds. Means maybe in some kind of maybe 1 second, 5 seconds, 6 seconds, like that. Okay, in a single digit seconds compared to tens of seconds for the open source drivers. Okay, so as new features, new service features are introduced, the goal of AWS suite of drivers is to have built-in support for these service features. Now, using enhanced monitoring to identify the operating system issues. So when enhanced monitoring system is enabled, Amazon RDS provides matrices in the real time for the operating system, that is OS, of your database instance runs on. You can view the matrices of your database instance using console. You can also consume the enhanced monitoring JSON output of the from Amazon CloudWatch logs in the monitoring system of your choice. For more information about enhanced monitoring, you can go on to this particular link, right? So if we enable enhanced monitoring, if you come here and if we go scroll down, right, inside the monitoring part, okay, so we have two monitorings, that is advanced and second one is the standard. Here you can see it retains 15 months of performance history, fleet level monitoring, and integration with CloudWatch application signals. Here the database insights, if I talk about, so of the standard version, so it retains 7 days of performance history with an option to pay for the retention of up to 24 months of the performance history. Okay, so if we have to retain for a longer time, for more than 7 days, in that case we will have to pay for it. Whereas in advanced, right, it will retain for 15 months by default, and obviously advanced insights will be a kind of somewhat a paid service in this particular case. Okay, so it's recommended, right? It's a good practice that if we are having our database clusters in the production level, in that particular case we should always go ahead with this advanced monitoring. We should not go ahead with the standard monitoring. Okay, now using matrices to identify the performance issues. Now to identify performance issues caused by insufficient resources and other common bottlenecks, you can monitor the matrices available for your RDS database instance. Okay, so again, how we will be able to identify the bottlenecks and how we will be able to identify the performance issues? Obviously by analyzing our matrices, right? What kind of monitoring we are doing, right? Whatever monitoring output we are getting from our CloudWatch, we will have to monitor it and we will have to figure out that what is the bottleneck of our instance is. It can be maybe a lesser RAM, it may be some kind of OS incompatible. Why I'm flittering every time? Incompatibility. Okay, OS incompatibility, right? So if the OS is not compatible in that particular case, maybe with the version of our database, right? Maybe our driver version and all those things, right? Again, if there is some kind of compatibility, okay, what is happening to me? Compatible, right? Incompatibility is there between our database and our driver. In that particular case, also, we will have to, like, there will be some kind of issue and there will be some kind of performance bottleneck in that case. Okay. Okay, I closed the tab by default. Compatible, incompatible. Okay, so viewing performance matrices, how we will be able to basically view the performance matrices and how we will get those informations. So you should monitor performance matrices on a regular basis to see the average, maximum and minimum values for a variety of time ranges. If you do so, you can identify your when performance is degraded. Okay, so we have to on a regular basis monitor the average, the maximum and the minimum values of the variety of the ranges that we are having. So if we do, we can identify the performance issues and the performance degradability. You can also set Amazon CloudWatch alarms for particular metrics threshold, so you are alerted when they are reached, right? So again, let's suppose if I'm setting a metrics threshold of my RAM, of my SSD, right, of my maybe networks, some kind of network, or maybe some kind of number of uh, concurrent connections and all those things. I can set those matrices, and when those matrices are reached, I should get alerted in that particular case. Now, to troubleshoot the performance issues, it's important to understand the baseline performance of the system. When you set up a DB instance and it runs in a typical workload, capture the average, minimum, maximum values of all the performance metrics. Do so at a number of different intervals. For example, for 1 hour, for 24 hour, 1 week, 2 weeks. This can give you an idea of what is normal. It helps us to get comparison for both peak and off peak hours of operation. You can then use this particular information to identify when performance is dropping below the standard level. Okay. So how we will be able to troubleshoot the performance issues? So first of all, we should understand the baseline performance. It means what is the performance, what is the least performance that we require. Okay. And to understand that, we will have to capture the matrices at different levels or at different intervals. So we can capture the minimum and maximum and the average values for 1 hour, for 24 hours, for 1 week and for 2 weeks, right? After understanding or after capturing the details of all these, right, we will have the idea that what exactly a normal system is, right? Maybe at let's suppose from 7 a.m. right till 10 a.m. there is around 200 to 300 concurrent users on my platform. Okay, so that is normal at that interval of time, right? Now the after 9 a.m. or 10 a.m. the number of users gets decreased. It gets somewhere around maybe from 100 to 150 or 200 users. So that is normal for that interval of time. Now in the evening again the concurrent number of users go rise up to, let's suppose, between 400 to 600 users, right? So that is the normal at that point of time. So we will have to do the comparison in intervals also, that between this time frame, this is a normal figure or this is the average figure that we are getting, right? What is the highest number of concurrent users we are having in that interval, what is the lowest number of concurrent users we are having in that interval, and so on. This is the kind of analytics that we have to do, and then ultimately we will be able to figure out and finalize what kind of performance, what kind of changes do we have to do inside our current infrastructure to meet the performance demands. Okay. Now, if you use a multi-availability zone database cluster, monitor the time difference between the time difference between the latest transaction on the writer database instance and the latest applied transaction on the reader database instance. This difference is called a replica lag. Now, what replica lag is, right? Let's suppose a transaction happened on my writer database at 1:30 a.m. Okay, I should go back here. Okay, now let's suppose there is this user. Okay, and this user write it. He wrote the data on my database at 1:30 p.m. something like this. Okay, now I will be checking my reader replica also, right? That at what time this information, maybe he did some kind of update operation. Let's suppose, right, or maybe some kind of insert operation. He did some kind of update. Now, when this get data, whatever row he updated, this user updated, that is reflected in my read replicas. So it maybe get reflected at 1:30. Let's suppose 15 seconds, right? 1:30, 50 seconds p.m. So this difference of 15 seconds is my replica lag. Okay, replica lag. So here in this case, my replica lag is of how much seconds? It's of 15 seconds. Okay, so it's just an example. Sometimes this lag can also be of a few minutes also, right? So this is what exactly a replica lag is. Okay, so you can view the combined performance insights and CloudWatch matrices in the Performance Insight dashboard and monitor your database instance. So to use this monitoring view, Performance Insights must be turned on for the database instance, right? And you have to go on to this particular link. Okay, again, we will have to turn on each and everything, right? Here we will have to select first of all the advanced thing. Okay, and here I believe there is something that we have not selected. Okay, let's say I'm using this, or maybe let's use the latest one. Okay, now this is done. This is done. Database identifier, it's fine. Let's keep it as self-managed. Happening. Okay, let's choose full configuration, Postgres. Okay, so it's perfectly fine. Okay, let's go ahead with the latest version here. Let's say dev and test I choose. Why to spend unwanted or unnecessary thing, right? Database cluster. Database one is fine. Master user, it's fine. Here if I do self managed root, okay, root, right? Password authentication will be there. It is fine. So we are going ahead with general purpose GP3. We are not connecting it, making it publicly accessible, let's suppose. And here if we are going ahead with the advanced thing. Okay, so you cannot change the PMS key after database has been created. Okay, it's fine. So okay, here you will be able to see the advanced monitoring part, enhanced monitoring. So here we have to set up this enhanced monitoring. So OS matrices granularity, let's suppose 60 seconds, right? So it can be, let's suppose, default itself, log exports. So we will export the uh, Postgres SQL logs and the update log also, right? And DevOps guru we don't need, and all these stuffs are fine, right? Here you can see enable the automated backups, right? Backup window, backup tags, and all these stuffs are maintenance, and all these things are given here for us to be selected. Okay, so this is what exactly it is talking about. Now you can create a performance analysis report for a specific time period and view the insights identified and the recommendations to resolve the issues. For more, you can see onto this particular link. Now to view performance matrices, you have to sign into your console and open RDS console, choose databases, choose the database and choose monitoring. The dashboards provide the information matrix, and this is what exactly I was talking about, because currently we don't have any kind of active database instance launched, right? In that case, I was not able to show you thing. The matrices default to show the information for the last 3 hours. The number, okay, let me do one thing. Let me launch this particular instance itself. Okay, so I will not enable the delete protection right now. Okay, and let me create the database. Okay, so it will start creating the database now. So the instance creation is done. Now it is trying to create. So the status of all the I would say machines here should be changed to available, and then only we will be able to see the monitoring part of it, right? Even if I click right now, so I'm not able to see any kind of monitoring thing here, right? Only when the status of it will be changed to available, then we will be able to see the details of the monitoring of it. All right, so now you can see that our database instance has been created, right? Now if I will click on this particular database, right, so you will be able to see this monitoring section that we are having, right? So it will take just a few seconds now. Okay, so now you can see we are having each and every monitoring that is there: active session count, right, active transactions count, block transactions, checkpoint buffer written, point lag, maximum point, right, requested, and all these things, right, because it has just initiated. So you can see it here. Mm. Okay, here you can see the different time zones that we are talking about. 1 hour, right? You can see for 1 day, 3 hours, 12 hours, 1 week, right? You can also customize it based on your own convenience if there is any kind of customization that is required. It should have more insights. Really, it should be. Okay. Okay, so here you can see, right, all the details here, right? Both of the three databases are perfectly fine. They are okay. Sorry, right? If there will be any kind of issue, right, any warning and all those stuffs will be here, right? Average DB load, maximum workload, right? Alarms if I have to set any, and all these stuffs will be available here for us to see, right? Click critical severity is here, high severity, medium severity, low severity, and all these things are here, right? Top 10 databases metrics, so CPU utilization, right, free memory, and all these things again are right here. Okay, if I want to check the database connections, right, network throughput, okay, read IOPS that I was talking about earlier, okay, then write IOPS, read latency. Okay, you can see here the read latency, what is the read latency, what is the write latency, and all these information you will be able to see here in your dashboard. Okay, so let's, so the dashboard provides the performance matrices. The performance, the matrix default shows the information of last 3 hours. Use the numbered buttons in the upper right page through the additional matrices to adjust the settings to see more matrices. Choose a performance matrix to adjust the time range in order to see the data for other than the current day. You can change the statistics, time range, and period values to adjust the information displayed. For example, you might want to see the peak values of a matrix for each day of last 2 weeks. So if so, set static to maximum, time range to last 2 weeks, and period to day. Here you will be able to see, right? If I come here, okay, and here if you check, so here you can do it as, let's suppose, relative, okay, not this one, set the statistic to maximum. So statistic value we will be able to find. Statistic, maybe in our RDS monitoring. Here, where is our statistic? It is talking about. Okay, let's say if I do 48, then I guess all other matrices will be also shown. Yes, it's loading. It's taking some time to get loaded. So total there are how many matrices? Total there are 135 matrices that are being counted here. Okay. So let's suppose if I do 128 here and continue. So you will be able to see almost all the matrices here in one single page. Okay, till then let's move forward. So you can also view the performance metrics using the CLI or API using the console. Now you can set the CloudWatch alarm. So sign into your AWS management console, open the RDS console at here, uh, navigate to pane, choose databases, choose database instance, then choose logs and events. In the CloudWatch alarm section, choose create alarm, right? And then send notification, yes, and all these things, right? So if I show you guys, so here if you see, okay, you have to come to RDS, right? And then you have to choose databases. So if I choose databases, let's suppose this database I want to do. Okay, and here we have to choose log and events, right? Choose log and events. Okay, so I will come here and I will choose log and events. Then in CloudWatch alarm section, choose create alarm. So okay, I guess it will be not for the whole cluster. If I do it for the database instance, okay. So here you can see, so I cannot set the alarm for the whole cluster right here. I will have to select that individual database instance, right? Now here you can see create alarm, right? CloudWatch alarm. So here you can see send notifications, yes, right? Send notification to ARN or maybe to new email or SMS topic. So let's see here what it's saying. So send notification, choose yes, and for send notification to choose new email or SMS topic. Okay, so let's choose new email. So for the topic name, enter the name of the notification, and with these recipients, enter the comma separated email addresses and phone numbers. Okay, so here I can give any topic name. Let's suppose RDS alarm. Okay, and here let's say this is the email that I want the mail to be sent. Okay, now for metrics, choose the alarm statistics and metrics to set. Okay, so I will come here. So let's suppose I want maximum of obviously the RAM users I will not be able to do in this particular case. Mm, let me see. I want to show you guys the mail to be triggered. Okay, so what things can I do currently? Okay, let's do disk output. So currently it's this much. Okay, so if I do average, so average is this. Okay. Threshold should be, let's suppose, less than or equals to, let's say 5% I'm doing here. Okay, so you can see here threshold I'm selecting here as 5 of 1 minute. Okay, and something like this I'm selecting. So and then I will do what? I will click here on create alarm. So okay, state is insufficient data. Okay, Okay, because currently it's not 1 minute, right? So in that case, it's saying insufficient data. So let's move forward. Ideally, it should set an alarm and send a notification to me. So for threshold, specify whether the matrix must be greater than or less than or equals to the threshold, and specify the threshold value. The evaluation period, choose the period, uh, choose the evaluation period for the alarm. For consecutive periods of a choose of the period during the threshold must have been reached in order to trigger the alarm. For name alarm, enter the name of the alarm and click choose alarm. The alarm appears on the CloudWatch alarm section. Now evaluating the performance matrices. So before that, let's see if this alarm gets triggered or not. Okay, so one alarm is done, right? And if I come here and open my email, okay, so here you can see I have received an alarm, right? I have received an email, right? And here you can see you have chosen for the you have to chosen to subscribe the topic. This is the topic name. To confirm this subscription, click on the view link, right? And if I click on this confirm subscription, so confirm subscription confirmed, you have subscribed. Your this is this. If you are not intended to subscribe, you can also unsubscribe it. Okay, so again, let's come here, and if you will check for the, let me refresh it. So now you can see the state is okay. And if I click on view now, so everything is okay. So ideally it should get triggered by now. Okay, so now let's understand how we will be evaluating the performance matrices. So a DB instance has a number of different categories of matrices, and how to determine acceptable values depends on the matrix. First of all, CPU utilization. So the CPU utilization, a percentage of computer processing the capacity used. Okay, so again, if I come back here, let me close all this, and if I come to monitoring part, okay, and here somewhere for sure we will be having the CPU utilization part. So here you can see, right, the CPU utilization matrix. So ideally it will take just a few seconds. So you can see here, right, how much percentage of the CPU has been utilized currently. So currently the CPU utilization is around 28%. Okay, so the percentage of computer processing capacity used is the CPU utilization. Now talking about memory. So freeable memory. So how much RAM is available on the DB instance in byte. The red line in the monitoring tab matrix is marked at 75% for CPU, memory and storage matrices. If instance memory consumption frequently crosses that line, then this indicates that you should check your workload or upgrade your instance, right? So here also in freeable memory, if I scroll down, so let me just scroll down till the last one time so that all the matrices will be loaded. Okay, so I hope it will now start loading all the matrices. And we are talking about, currently it's D. We have to go to freeable memory, right? So deadlock, disk IO, disk input output utilization. It will be in alphabetical order so that whenever you have to search any metrics, you will not be have to go to and fro. So here you can see freeable memory matrix is here. It will take just a few seconds to load again. So okay. Really, it should not take this much of time to load. Okay, so you can see now the freeable memory is here and we can see in bytes. So these memory are in bytes, right? So this much memory is free and we will be having a red line. So if this freeable memory gets reduced, so we will be having a red line which will indicate that you have utilized the 75% of your CPU in this particular case, or maybe your memory and storage matrices. So if it is frequently crossing that particular 75% of the line, in that case, you can consider upgrading your instance, or you have to check your workload or maybe your query that if it is creating some kind of bottleneck or not, right? So again, this is what the freeable memory is about. Then we have the swap uses. So how much swap space is used by the database instance in bytes? So swap instance will for sure be in the category F. So we will have to scroll down for that. So this is O. Then again, this is O. This is O. Let me load it for once so that we don't have to wait every time. Because there are around more than 130 matrices that it has to count, right? So it's taking a bit time to load. So this is again a one-time job, right? Once you have loaded, you will be getting all the values right here in front of you. So, and this is what the issue of scale is, right? Now you can see organization as big as Amazon itself, right? It's taking this much of time to load the matrices because we are having a large number of charts here, right? We have to deal with 130 charts around. So even as organization as big as Amazon are, they are not able to load it in a fraction of seconds. It has some kind of latency for it. Okay, so here you can see now it has started to load. Okay, and we had to talk about the swap memory, right? swap uses. So here you can see the swap uses is there. It's still not loaded, I guess. Will be taking some time to load the values. Okay, so here now you can see the swap users matrix is here, and it is in which it is in bytes. Then talking about the disk space, so we have free storage space. So how much disk space is not currently being used in the DB instance in megabytes, right? So we will have to scroll for F here in this case. So free space, if I talk about, okay, free storage space, you can see, I guess this is not the one. Free storage space, right? Yeah, this is the one, right? Free storage space. It is in bytes itself. Okay, ideally it should be in megabytes. Okay, you can see here. So 208 billion 332 million 382,208 bytes of memory is currently available for me. Okay, so you can see here in free space category. Then input output operations. So similarly, read IOPS and write IOPS. The average number of disk read or write operation per second. Okay, then read latency and write latency. So the average time of read or write operations in milliseconds, right? So read IOPS and write IOPS will have an interval of seconds, and the read latency and write latency will have the interval of milliseconds. Then read throughput and write throughput. So the average number of megabytes read from and written to the disk per second. Then queue depth, so the number of input output operations that are waiting to be written on the disk. Okay, so queue depth again is one of the major matrices that we have to consider, right? Okay, queue depth. Okay, queue depth should be PQR. OPQR, right? O is here. Okay, we don't have any queue depth. Scroll at top, and here if I want to search the matrix, okay, I can also search the matrix here. So let's suppose I search Q. Okay, so this is average queue length and disk queue depth. So it has been now renamed to disk queue depth, right? So this is the queue depth that we are getting. Okay, then network traffic. So network receive throughput and network transmit throughput. So the rate of the network traffic to and from the database instance in bytes per second. Then we have the network connections or the database connections. So database connections are the number of clients sessions that are connected to the database instance. For more detailed individual description of the performance matrices available, you can go on to this particular link. Now, generally speaking, acceptable values for performance matrices depend on what baseline looks like and what your application is doing. Investigate consistent or trending variations from your baseline. Advice about specific types of matrices follows. So high CPU or RAM consumption. So high values of the CPU or RAM consumption might be appropriate. For example, they might be also if they are in keeping with your goals for your application, like throughput or concurrency are expected. Disk consumption. So investigate disk space consumption if space used is consistently or at above 85% of the total disk. If it is possible to delete data from the instance or archive the data to a different system to free up the space. Okay. Network traffic. So for network traffic, talk with your system administrator to understand what expected throughput is for your domain network and internet connection. Investigate network traffic if throughput is consistently lower than expected. Database connections. Consider constraining database connections if you see a high number of user connections in conjunction with a decrease in the instance performance and response time. The best number of user connection for your database instance will vary based on your instance class and the complexity of the operations being performed. To determine the number of database connections, associate your database instance with a parameter group. In this group, set the user connection parameter to other than 0. That is, so if you have set the parameter connections as 0, it means you have unlimited connections allowed. Like you have allowed unlimited connections, I would say. You can either use an existing parameter group or create a new one, and you can go on to this particular link for more information. Then IOPS matrices. The expected value of IOPS matrix depend on the disk specification and server configuration. So use your baseline to know what is typical. Investigate if values are consistently different from than your baseline. For best IOPS performance, make sure your typical working set will be fit into memory to minimize read and write operations. Okay, so these are the things that we can do in order to check about maybe the high CPU or RAM consumption, disk consumptions, network traffic, database connections, and IOPS matrices. For issues with performance matrices, the first step to improve the performance is to tune the most used and most expensive queries. Tune them to see if doing so lowers the pressure on the system resources. For more information, we have to go to tuning queries link. If your queries are tuned and issue persists, consider upgrading your Amazon DB instance class. You might upgrade it to one with more resources, that is having more CPU, more RAM, disk storage, and network bandwidth and input output capacity that is related to the issue. Okay, so first of all, if you are getting some kind of issues with any of these, maybe high CPU consumption, right? Maybe not database connections, I would say, mostly with the high CPU and RAM consumption. So first of all, we should try to improve the query, right? We should write optimized queries, right? Optimized SQL queries for fetching the data and even for the insertion of the data. If we feel like that the queries has been tuned, the queries are optimized, right? Here we will see how we can optimize the queries, right? If we feel like that we have optimized queries and we have tuned our queries, even though the issue persists, in that particular case, we will have to upgrade our database instance. Okay. Now, tuning queries. So this particular question I get a lot, right? Most of people say that, okay, how we can optimize queries, right? How we can write good queries and all those stuffs. So you can very well see for each and every database kind of engine, right? It is here given not in a generic way, but for specifically all the database engines, what kind of tuning and what kind of performance upgrade you can do. So on one of the best ways to improve the database instance performance is to tune your most commonly used and most resource intensive queries. Here you tune them to make them less expensive to run. For information on improving queries, use the following resources. Okay, so for MySQL, we can see optimizing select statements in the MySQL documentation. For additional tuning resources, we can go on to this particular link, right? So this is the official documentation link of MySQL now, right? And we can see here that how we will be optimizing our select statements. So we can give where clause optimization, we can give some kind of range, index merge optimization, hash join optimization, condition engine, nested loops, and all these stuffs are given right here. Okay. Talking about the Oracle database, so and other optimization techniques are also given here. Okay, so we have the white papers, presentations, case studies, and all these things, right? Here you can see even the Mumbai Stock Exchange BSE meets 900 plus 900% trading growth by scaling with MySQL Enterprise Edition. Okay, and all these things are given here about the performance tuning and resources. Then talking about the Oracle database. So we can see this database SQL tuning guide for the Oracle documentation. Okay, so if I click here, so here you can see how performance tunings can be done. So introduction to SQL tuning, SQL performance methodology, and all these things are given here. Different things, we can read it. Talking about the SQL Server one, so see analyzing a query in Microsoft SQL documentation. You can also use the execution, index, IO related data management views, that is DMVs, described in the system dynamic management views in the Microsoft documentation to troubleshoot SQL queries issue if any, right? So we can also visit this thing, or also we can also understand how we will be able to analyze our query. Okay, so again the documentation is given here. We will not be covering these things because if we start covering these things, obviously it will take us a few days. So we are not going to waste too much of time on this particular thing. Okay, so a common aspect of query tuning is creating effective indexes. For potential index improvements for your database instance, see this particular link in the Microsoft documentation. For information on using tuning advisor on RDS for SQL Server, you can go on to this particular link. Now for PostgreSQL, see using explain in the PostgreSQL documentation to learn how to analyze a query plan. You can use this information to modify a query or underline tables in order to improve the query performance. So again, you can go on to this particular link for understanding the Postgres query plan. Means if you are writing a query, right? So how Postgres will plan to execute that particular query. Okay. Even though if you write select star from the table, right? It's not that first of all it will select all the rows and then it will check for the table. The query execution is totally different. Okay. Currently I will not be talking about it again, as I said. Okay. Let's keep it for some other day. And for MariaDB, you can see the query optimizations in the MariaDB documentation. Now the best practices for working with MySQL. So both table sizes and the number of tables in MySQL database can affect the performance. Okay. So you can very well see here that we should also not create a large number of tables, right? And we should also not create lesser tables so that my table size gets too huge, right? So we will have to keep a correct balance between our table size and the number of tables inside MySQL engine. So if I talk about the table size, so typically operating system constraints on the file size determines the effective maximum table size for the MySQL database. So the limits usually aren't determined by the internal MySQL constraints. Okay, so MySQL internally does not have any kind of constraint on the table size, but the operating system on which you are running the MySQL database, that has some kind of file size constraints, and using that particular constraint, that constraint automatically gets transferred through the MySQL database also. So on the MySQL database instance, avoid tables in your database growing too large. Although the general storage limit is 64 TB, provisioned storage limits restrict the maximum amount of MySQL file to 16 TB. Okay. So, or guys, let me do one thing. Okay. So I will be creating a separate video for this best practices part. Okay. Because okay, so what I will do is, because this video is already getting too long, right? It is already a long video, right? So what I will do is I will try to create a new video for this particular thing, for the best practices part of it, so that I will be able to explain the things in a greater detailed way. Cool. So I will be ending this video here itself. I will be covering the best practices for working with all the databases engine, not only MySQL. I will be covering MySQL, I will be covering MariaDB, I will be covering Oracle database, Postgres, and Microsoft SQL Server, right? So this was pretty much it for this particular video. I hope you guys learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye-bye.